In this video, I'll show how to derive the E field a distance d from an infinite wire. And to do that, you just need to find the E field a distance d from a finite wire, and then take the limit as the length of the wire approaches infinity. So first, here's the setup to find the E field a distance d from a finite wire. The wire goes from negative L over 2 to L over 2, has a charge lambda, and we're looking for the E field a distance d from the wire. So what we're going to do is take a sliver of the wire, find the E field that generates at the point, and take the integral from negative L over 2 to L over 2. So we know that the equation for an E field is E equals KQ over R squared times R hat. We are going to be looking for dE, which means that the equation we're looking at is K times dQ over R squared times R hat. We can find both dQ and R from this picture over here. We know that the sliver has the width dx, which will have the charge dq. We know that charge q is equal to lambda times L, which means dq is equal to lambda times dx, and R is equal to the square root of d squared times x squared. So, back to this equation for dE, we can plug in dq and R squared to get dE equals k lambda dx over x squared plus d squared R hat. And we know that dE is made up of its x and y components, but we know that dx is equal to 0 due to symmetry. Because for every dx coming from this angle, there'll be an equal one coming from this way, so dex will be equal to 0. So all we need to solve for is dEy, which again from this picture is going to be equal to dE times the sine of theta. So dEy equals k lambda dx over x squared plus d squared, dE, times sine theta, which from the picture is going to be d over r, which is d over x squared plus d squared to the 1/2, so the square root of x squared plus d squared. That is equal to k times lambda d dx over x squared plus d squared to the 3/2. Take the integral of that from negative L over 2 to L over 2. And you're going to get k lambda L over d times root d squared plus L over 2 squared. So that is the equation for the E field a distance d from a finite wire. So to find the equation for the E field a distance d from an infinite wire, simply take the limit as L approaches infinity of the equation that defines the E field a distance d from a finite wire. D squared becomes negligible, so you can get rid of it, and you simplify the equation to get the final answer of 2k lambda over d.